removing the bushing from the oil storage tank and positioning it horizontally on the floor. Before raising the bushing out of the oil tank, lay out a long line of oil-absorbent sheets, equivalent to the length of the bushing, on the cement portion of the floor. Using the sling that's choked under the large brass nut at the top of the bushing, begin raising the unit out of the oil. When the bottom of the bushing reaches the top of the tank, a team member should hold a few sheets of oil-absorbent material around the bottom flange of the conductor core to help absorb the oil dripping down off the surface of the main insulation. Continue holding the sheets around the flange until the crane operator has moved the unit over the line of sheets on the floor.
Hang on, let's just sweep this stuff off. Okay. Okay, I'm going to take it west. Watch for any dripping above you. That's actually pretty good.
Move the unit northbound following the path of the sheets on the floor, and then lower it onto the bottom piece of plywood.
Okay, I'm going to take it north now. Nah.
We're coming out pretty good, eh?
Oh yeah.
Watch your back, Graham.
Okay, I'll take it a little bit more north, or are we pretty well in line there? Not too bad, eh? Okay. Now the only thing I need is for that knot to be the back a bit. Right about there, that's good. And I'm going to start taking it south as soon as I'm down. Okay. Now I'm going to take it south.
With the bushing still resting on the wood, begin lowering the top of the bushing over the line of sheets on the floor. As the unit slowly tilts down, there will be a sudden increase in oil dripping onto the sheets.
And that's the reason for the oilcloth on the floor.
If the oil begins to pool in any spot, simply apply more oil-absorbent sheets to that area. Continue using extra sheets as the bushing becomes horizontal.
Oh, yeah. Yeah, I'll take it down. I'm going to take it down a bit first. Okay, going east. Okay, going south again.
Before the large flange in the center of the unit touches the ground, insert a resting stage directly under the ground sleeve so that the heaviest part of the unit is supported by the stage.
going to throw a little bit of oilcloth on that one there, Sam. Yeah, oh, here's a piece.
Prior to
Yeah,
the
just
main
throw that across
insulation
there.
making contact with the
Perfect.
resting stage at the top, cover the stage with oil-absorbent sheets. When the unit is stable, begin removing the old gasket material that remains on the underside of the bottom rim of the ground sleeve.
It's not too bad.
Removing old gaskets from the flange and preparing surfaces for new gaskets. After the bushing has been removed from the oil tank and is supported by wooden resting stages on the floor, begin unthreading the large brass nut at the top end. Manually unscrew the nut and slide it completely off the conductor core. Using a chisel, remove as much of the old gasket material that still remains on the top of the flange. Take a sheet of oil-absorbent material and wrap it over and around the main insulation just above the crown of the flange. Tuck the very edge of the sheet tightly into the corner between the main insulation and the flange. The cover sheet will prevent the main insulation from contamination from airborne particles during the time it takes to remove debris. Similarly, wrap a sheet of the oil-absorbent material over and around the main insulation just below the top rim of the ground sleeve. Tuck the very edge of the sheet tightly into the corner between the main insulation and the ground sleeve. Using a small pneumatic drill with the appropriate attachment, begin grinding off the remaining debris that is too small to remove with a chisel.
Pit, and we're going to flip it right side up. Okay, and then we're going to put it back in the pit and put the upper half on. Okay?
And yeah, so in the meantime now he's just cleaning,
He's
scraping off the old, and you're going to put on the
Prep-
new,
prepping,
clean it, and
yep.
then put on the new,
Yep.
the new gas.
Exactly. Now, while it's in this position here now, we're also going to change, there's a ground.
When finished grinding, spray the area with isopropyl alcohol and then wipe it clean with a lint-free cloth. After wiping the area where the gasket was, remove the cover sheet. Spray and wipe the area under the ground sleeve in the same way. Servicing the inner core metal tube of the bushing and gasket at the transformer end of the bushing. Extract the conductor core just a few feet out of the bushing by pulling on the bottom flange to allow some of the oil to drip off and onto the absorbent material below. Have 2 resting stages in place to support the conductor core when it has been entirely extracted from the bushing. With the help of an additional team member stationed at the bottom of the bushing, pull out the entire length of the conductor core while continuing to support it above the floor. When the top end of the core comes out, rest both ends on the resting stages that are in place. Use sheets of oil-absorbent material to wipe the core of excess oil. Do not wipe the core with the same cloth used to wipe the floor. The cardboard spacers should be above or below the resting stages, but should not rest on a stage. Wrap a cloth around the base of the conductor core just above the lower flange, and then secure it using masking tape wrapped around the core. Using a small pneumatic drill with the appropriate attachment, begin grinding the remaining debris that is too small to remove with a chisel. The cloth will protect the core from contamination from airborne particulate matter. Clean the underside of the flange using the same procedure. Use a thread cleaning chaser tap to clean the threads in the 2 holes in the large flange that will be used to screw 2 large eye bolts into. The holes used for the eye bolts are dedicated for this use and are located 180 degrees apart from each other on the flange. Spray and wipe the conductor core with isopropyl alcohol as it lies supported on the resting stages. Use a Scotch-Brite type scouring pad to remove any debris as it's being wiped and sprayed.
Okay. Really, and after you look at a few of these bushings, you know, you're going to see how they're really all the same. It doesn't matter whether they're this big or this big. They really work on all the same principle.
Screw both eye bolts into the holes that were previously cleaned. The bolts should be screwed into the flange on the ground sleeve side and should have as many washers as necessary to adjust for the thickness of the flange. The holes to insert the eye bolts are on opposite sides of the flange. Attach the end of a sling to a shackle and then secure the shackle to the eye bolt by inserting a bolt through both legs of the shackle with the eye bolt in between. Repeat the same process to connect the sling on the opposite side. Install the new gasket for the top of the lower flange by moving it down the length of the conductor core, trying not to make contact with the core. Make sure to lift the core to advance the gasket past the resting stages. Have a tube of gasket adhesive ready to install the gasket. Wipe the surface of the flange where the gasket will be seated, and then apply the adhesive to the bottom surface of the gasket. Apply the adhesive as a continuous line in the middle between the inner and outer diameter as it's rotated 360 degrees. Press the gasket to the surface, and then by lifting the gasket up and down a few times, it helps to spread the adhesive underneath, as well as allowing air in to speed up the drying process.
Actually, I'm doing this because it allows a little bit of air to get in between, and it actually speeds up the drying process, makes the glue a little tackier, quicker. You can see it there.
Replacing O-rings and gaskets on the ground connection port on the flange.
Okay.
Clean the top of the port for the ground connection on the flange by spraying it with isopropyl alcohol and then using a cloth to wipe off the grime that has accumulated.
Excess dirt off. Okay, there you go, Lloyd.
Begin removing the 4 bolts on the top of the smaller raised platform of the port using a ratchet wrench. When the bolts are removed, lift the cover off to reveal the grounding system, the purpose of which is to ground the core of the bushing to the flange, which in turn will be grounded to the transformer when bolted in at the time of installation. Begin loosening the 4 hex screws on the larger raised platform using an Allen key. Use a longer hollow extension pipe to leverage the smaller key and make it easier to loosen the screws.
From the flange, of course, it would be automatically be grounded to the transformer once it was the bushing was bolted into the transformer.
Is it grounding or bonding?
Grounding.
Notice the brass spring-loaded collar that surrounds the pin in the center. When the collar is in the default position, raised and level at the top with the center pin, then the conductor core is grounded to the flange. However, when the collar is depressed, then there is an open ground and the core is no longer grounded to the flange. Remove the loosened hex screws from the larger raised platform and then lift the top off.
And now you'll find a pin with springs under there, O-rings. Let's make sure we get them all in the right spot again. Okay.
The spring
Good.
underneath the collar is now visible as it sits on the pin between the nut below and the collar above.
This one here. There it is. Belongs with those. Okay. So now what we got to do here,
The O-ring on the top of the smaller raised platform must be replaced, as well as both O-rings surrounding the pin on the bottom half of the larger raised platform. Slide the spring and the collar up and off the pin.
see if I can get this separated first.
Clean around the O-ring to remove any debris that might be lodged in between the O-rings.
Okay, Lloyd,
Can I help?
we're having a, she's being stubborn.
You want me to grab the special gasket removal tool?
Yes, please. That means the torch.
Ah, the old torch.
The gasket removal, yeah. Actually, this,
You got the O-ring out or not?
no, there, well, what it is it's sealed in here. This seal has got to be, we got to somehow get this out.
Where's the O-ring?
There's, well, that one there, but there's also,
Using a small pick, remove the larger and thicker O-ring that surrounds the smaller one closer to the pin.
that was an O-ring, believe it or not. And we just have to,
Use the same pick to remove the smaller O-ring around the pin.
there you go. There's one, there's two. And now you can remove.
Insert the narrow end of the pick used to remove the O-rings into the hole on top of the pin to loosen it and pull it up. When it's loose, lift it up, being aware that it is attached to the ground wire underneath the cover to the port below and will only extend about an inch. The O-ring that surrounds the port leading to the core will also have to be replaced.
Okay, there's another O-ring right there. That has,
The top part of it? He's gonna pull it right.
Loosen the nut at the base of the pin by inserting a narrow pick at the top to hold it, as the nut is loosened using an adjustable wrench. Once the nut is loosened, manually unscrew it all the way off and lift off the star washer and red cover to the port below.
okay.
Remove the gasket at the base of the pin and save it to use as a reference when making a new one.
Or nitro. Okay. Is it? Oh yeah, definitely corporine. Okay, that's it. So now we're going to replace that one. Pardon me.
Remove the O-ring that surrounds the port leading to the core.
What's that?
Put it in the vacuum. I didn't open the valve yet to the bushing tube.
Yeah.
Remove the O-ring on the top of the smaller raised platform.
So that's good. You're good though.
Yeah, oh, it's
Excellent.
fine. Huh?
Yeah. So that's what it was. Just a leak in the cap tap.
Punch out a new gasket to replace the one that was removed from the base of the pin.
Why drop it inside the core? You got
A punch. I just punched them out.
Place the new one back over the pin and slide it to the base. Obtain new O-rings identical to the ones that were removed. Install the new O-ring into the top of the smaller raised platform.
Thank you, Mike.
Yeah, that's good.
Install the new O-ring into its position surrounding the port leading to the core and under the cover that will rest on top of it.
Ready? Next one. Goes where? Go ahead.
Also install the larger and thicker O-ring that surrounds the O-ring around the pin.
Next one goes when? Other one.
Place the red cover back onto the port leading to the core and place the washer onto the pin so it rests on the cover.
Yeah, lock washer.
The top of the nut that screws the star washer onto the cover is tapered on the inside at the top end and also has beveled edges at the top end. The bottom end does not have beveled edges and is flat instead. When installing the nut onto the pin, the tapered beveled edge should be on the top and the flat end should go against the star washer. Use an adjustable wrench to tighten the nut.
Snug it up. Puts a little compression on that corporine gasket that's on the other side of that pin. That creates your seal there so the oil cannot come up through.
Push the cover into place and then install the O-ring over top of it.
Now what are you doing?
Just pushing it down into place,
Okay, good.
and that's
Now
the
here we go.
that's the final seal right around where the
Here. Okay.
goes in. Yep.
Okay. 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 Nice and slow. Go ahead.
Place the spring back onto the pin.
It's just getting the other part that goes on top of the spring.
Retrieve the collar from the location where it was kept when first removed. In this case, a hex screw hole in the cover was used to effectively store it. Place the collar back on top of the spring. Ensure all the O-rings are firmly in place before putting back the top half of the larger raised platform. Spray the underside of the top half of the larger raised platform and wipe it clean with isopropyl alcohol. Place the top half back onto the bottom half and insert the hex screws by hand.
All right. very
Tighten
good.
the hex screws using an Allen wrench.
Yes.
Iron Hall.
Fully tighten the hex screws using an Allen wrench in conjunction with a hollow pipe. Replace the cover on the smaller raised platform and tighten the bolts manually. Fully tighten the bolts using a ratchet wrench. Orienting the bushing from horizontal to inverted position and placing it in the service well, and installing the gasket for the bottom porcelain insulator. Hoist the top end of the bushing about 1 foot off the resting stage using a sling choked around the long cardboard insert at the top of the bushing. Slide the resting stage out from underneath the bushing and lay a few extra sheets directly under the opening to the top end of the outer metal core that the main insulation is wrapped around. Gently lower the top end of the bushing down onto the extra sheets that are on the floor below it.
Pardon me? Go, yeah.
The 2 large eye bolts are currently installed on the underside of the flange. Before the bushing is lifted, the eye bolts need to be repositioned in such a way that they are on a plane parallel to the floor during the lift.
That should be hunky-dory.
Everything with a spreader at the top.
What's that?
Fine. I was thinking about a spreader at the top, you only issue the one.
Oh, no, that'll be absolutely fine.
Really good.
Yeah. So what I'll do is I'll start lifting it, and I'm going to bring it a little bit east so I can make a straight lift up.
To rotate the bushing, attach the 2 slings to the hoist hook and then slowly move the hook eastward so that the bushing rotates to the correct position while resting on the stage positioned under the ground sleeve.
Good job, bushing team.
Okay, I'm going to start lifting it now. And I'm going to come east.
In order to align the bushing, lift it just off the resting stage and then eastbound so that its length is parallel to the edge of the metal flooring.
That should be just about right there.
Begin hoisting the flange so that the bushing is oriented vertically upright and upside down.
Yeah, it's just a little bit of oil.
Extra sheets of oil-absorbent material may have to be dropped onto the floor to absorb dripping oil as needed.
A little residual oil.
Drop extra sheets of oil-absorbent material around the area where the bushing makes contact with the floor to absorb the oil flowing down off the core. As the unit is being raised upright, minimize the burden of weight on the end of the bushing that's touching the floor by slightly raising it off the ground just before it becomes vertical. This will eliminate the heavy weight at the top, where the metal flange and ground sleeve are, from forcing the lightest end of the bushing against the concrete floor at the bottom. With the bushing still
Okay, taking it
suspended
east.
slightly off the floor, remove the cover of the service well into which the bushing will be lowered, and then move the bushing towards the well. Note that when in the service well, the bushing will come to rest on the crown of the flange in this inverted position. The crown has a smaller diameter than the base of the flange, so the service well will be different than the one it was in when it was not inverted.
We weren't worried. We knew it was going to happen. We had it all
Slowly lower the bushing all the way into the service well, while 2 team members guide it down to prevent it from having any contact with the edge of the metal flooring around the top rim of the well.
Now these things are sticking out. Are they?
Yeah, that's not good. No, that's not an issue. Whoa, watch. Yeah, we're coming down.
Okay,
No, keep it perfectly centered.
see what you're saying.
Keep it centered. There we are.
It's on the bottom flange, right?
Yep. Right there. Perfect.
All in.
Good. All right.
Install the new gasket onto the underside of the ground sleeve using gasket adhesive and wearing appropriate gloves.
Now we're going to take the porcelain and put it on. So I'm going to...
Placing the lower porcelain insulator on the inverted bushing. As the lower porcelain insulator rests inverted on the floor, connect the sling that was previously choked onto the narrow end to the hoist hook.
Okay, I'm going to take it a little bit more east, center, just to center it up a bit. Watch your head there, Lloyd.
Remove the slack from the sling and ensure that the ends of the sling are aligned properly at the point where they choke the porcelain. Slowly lift the porcelain about 3 feet off the ground.
Okay, I'm just going to make an adjustment here. That looks quite good. Yes, everything's been cleaned. You can take a rag though and just give it a quick wipe down with any dust on the outside.
Wipe off any dust or debris that may be on the surface. Move the unit north and closer
Just
to the
cleaning the
inverted
gasket
bushing
surface.
in the service well.
Okay, that looks good. Okay, now I'm going to take it a little bit more north first. I'll take it up. And if we could get away with using glue at all, we would try to avoid it.
Sam?
Yes,
Team member Sam is still here.
stuck in the back way. He's in the basement.
As the unit is raised to just above the bushing, a team member should guide the porcelain with both hands as it descends over the main insulation.
A little bit more south, maybe. Okay.
Just before the porcelain is lowered directly onto the gasket,
Your gasket nice and
check to make
centered.
sure that the gasket is
That.
centered and is lying flat on the ground
Yeah.
sleeve.
Okay, you want to make any adjustments? I think you might have to come. Has to come my way just a fraction.
If everything looks in order,
That
lower
looks
the
pretty darn
porcelain
good.
all the way down so that it is seated in the center of the gasket.
That looks not bad. A little tight here, but not. We could go east a fraction.
How's the north south? I could go south just a tad.
We can go south as well, yeah, so. Hang on, I'm just gonna touch it up a bit.
Raise and lower the unit as required to get the optimum seating, keeping in mind that porcelains are not always perfectly round.
I like that. A little bit right there. Now don't forget, the porcelains are usually a little bit oval, they're not perfectly round. Yeah, I think this is good. Eh?
Gaps all the way around. My side, instead of coming to the outside here, it's just flush.
Yeah, that's not bad. That's acceptable. Okay.
Install the central metal core via crane into the inverted bushing through the lower porcelain insulator. Attach 2 eye bolts to the underside of the bottom flange of the conductor core and adjust for the length of the bolts by using an appropriate number of washers. Attach the ends of a thick wire cable to a shackle, and then attach each shackle to an eye bolt by connecting each leg of the shackle to the eye bolt in between.
Good.
Lower the hoist hook to within distance of the cable and make the connection.
In what way?
We're gonna have to go back today, fill it tomorrow.
Fill it tomorrow. It's got to sit for.
Double up on the absorbent sheets that the other end of the conductor core is resting on.
Good catch, too. Okay, here we go.
Begin hoisting up the conductor core using the cable attached to the bottom flange.
Okay. Pretty steady there.
When the core is vertically aligned directly above the inverted porcelain, a team member using a small stepladder should guide the core into the porcelain as the crane operator lowers it.
Anything less than an inch, maybe. How about it?
Okay, watch the threads around the porcelain. There you go. That's about the only thing that could damage it. So you'll have to keep guiding. Those cardboard cylinders there, they're larger diameter. They can get hooked up too.
Care must be taken not to damage the cardboard inserts installed at intervals along the core as it is being lowered. Lower the core all the way into the bushing. Just before the flange makes contact with the gasket on the porcelain, ensure that the point of contact is centered and seated correctly.
Just a slight amount.
If everything looks in order, lower the flange all the way down onto the porcelain.
How's that gap all the way? really doesn't look too bad. I think we're pretty good there, Graham. Okay. I'm going to bring it down. You can disconnect it.
Lower the hook and disconnect the shackles, and then the eye bolts. Attaching the compression jig to the lower porcelain insulator. Attach 2 eye bolts to the underside of the large retainer plate that is used to support and retain the bottom flange to the conductor core when the compression system is not in place. Attach the 3 connecting rods to the plate and hoist it via a sling that's attached through the bolts. While the bushing is seated upside down in a service well, remove the shackles that were used to move it there, and also the eye bolts the shackles were attached to.
Just got to get her level.
Continue to hoist the plate with the connecting rods attached to it and hanging down from the plate. Slowly move the retainer plate closer to the bushing in the service well.
Heading east first.
2 team members can help guide the plate as it moves towards the bushing. As the retainer plate gets closer to the porcelain, raise the plate above the bottom flange, being careful to avoid any contact between the metal rods and the porcelain. Lower the plate down from directly above the bottom flange on the bushing. Lower the plate in very small increments so that the 2 team members can insert the hanging rods into the appropriate holes in the flange. Using a ladder, the crane operator can ensure that the flange will be seated on the center of the plate.
Right.
Mark the bottom there, right?
Yeah, right there.
That's the plate we were using.
Ensure that the 3 connecting rods are in the proper holes in the flange.
Now.
We're going to have the solder on here.
Use the appropriate number of washers in combination with the large nuts to obtain a tight connection of the plate to the flange. Hand tighten the nuts to the washers. Tighten the nuts firmly using an adjustable wrench.
Beautiful.
Remove the inverted bushing from the service well and place it horizontally onto the floor. Below ground level in the service well, the main insulation on the upper section is above the large brass nut as the bushing is seated in an inverted position. With shackles attached to eye bolts mounted on the bottom of the retainer plate, slowly lift the bushing out of the service well with the help of 2 team members guiding it out and protecting the main insulation.
Okay, so Lloyd, what we're going to do is we're just going to take it down. We can just take it straight across, and I'll lay it down.
Look at that core a little bit. We're actually going to bend it, put it on the core when it's dropped in.
Yes. Yeah, so we're actually clear of that little cylinder or the disc.
Anybody asks us about the Corona sheet until we get it
That's
You
not.
covered up at lunchtime in that van. That's our plan anyway. Unless you're still like up and heard that nothing's gonna happen. Yeah, there's really no issues with that.
No, there isn't.
Slide it back.
Just going to slide it back on. A couple of drops of glue around the outside. You know, that Loctite.
There's no need to even do that.
No. Okay, so we're
Put the cover back on the service well as soon as the top clears ground level. Prepare the area where the bushing will be positioned on the floor by spreading out sheets of oil-absorbent material.
yeah, we're going to just drop it straight down here. Yes. Yep, perfect. I just flipped that over.
Place plywood boards at each end of the sheets that are on the floor.
That looks a little better. Okay.
Move the bushing to the north end of the row of sheets to just above the plywood board.
Okay, I'll take it back to that plywood there. So I'm going a little bit north. That should do. I'm going to take it a little bit. I'm going to take it down. Okay, it's starting to tip now.
Lower the top of the conductor onto the plywood and then tip the bushing by lowering the top end of the bushing with the retainer plate on it toward the south end of the row of sheets on the floor. Slide a resting stage under the second tier of the main insulation a few feet south of the large brass nut. The resting stage will help support the weight of the main insulation between the flange and the top of the conductor core. Lower the bushing so that the flange comes to rest on the plywood board at the south end. Moving the bushing from the horizontal position to the service well in a vertical position. Slip the large brass nut onto the conductor core at the top end of the bushing and slide it down until it makes contact with the threads on the core. When it reaches the top thread, apply downward pressure on the nut while turning it counterclockwise. This will ensure that no cross-threading has occurred before beginning to screw it on. Begin to turn the nut clockwise to tighten it to approximately halfway down. With the help of two team members, slip the long cardboard insert over the large brass nut so that it comes to rest on the top level of the second tier of the main insulation.
There it is. Perfect.
To protect the threads under the brass nut, wrap a section of oil-absorbent material around the conductor core just under the brass nut and choke a sling around it to protect the threads on the core.
From sliding off once we lift it up, yeah.
Begin lifting the top of the bushing while the retainer plate at the bottom remains on the floor.
Okay.
Continue lifting until the bushing is in an upright position and the bottom is just off the floor at the south end of the row of sheets on the floor.
Now we're going to take it over to the hole.
Move the unit north above the row of sheets, as far north as the service well, and then move west in the direction of the well.
Already high enough. I'm just lining it up. Okay, I'll stop right there.
Remove the cover to the well, and then, with guidance from a team member,
Might have to go back a little further. That's it.
lower the bushing slowly all the way into the well.
At this point, not really, because we're gonna, I don't know, where is it right now? Well, we'll bring it down and we can spin it.
Gotta pull up, take this off anyways, right?
Yeah, after it's, before we put it on vacuum. Oh, the cap tap is right over there then, so. Yeah, that looks pretty good right there. That's perfect. The ground went very well.
The service well used here must be able to accommodate the 3 rods used to attach the retainer plate to the flange on the bushing. When lowering the bushing, carefully consider where the capacitance cap should be facing in order to optimize the refurbishment process. Using the rolling warehouse ladder equipped with handrails and with the locking mechanism activated, loosen the choke below the nut and remove the sling as well as the material underneath it. Unscrew the large brass nut using both hands. And remove it from the bushing. Replace the upper porcelain insulator onto the bushing, install gaskets, and remove lifting straps. Using the rolling warehouse ladder equipped with handrails and with the locking mechanism activated, attach the slings that are choked around the top of the porcelain to the hoist hook.
Right here.
Attach the shackle to the shortest sling, and then signal to the crane operator to begin lifting the hook to remove the slack. The team member on the ladder should support the slings as the slack is being removed and until a balanced lift can be confirmed. The 2 slings that are being used are choked around the porcelain between different sheds. The purpose of attaching a shackle to the end of the shortest sling is so that both slings will be closer to the same length, thereby optimizing a balanced lift. Using the ladder, drop the new gasket for the top of the flange over the main insulation and let it fall. Slide the metal band used to connect the 2 metal cores onto the inner conductor core. Connect the wire to each band by using an adjustable wrench to tighten each nut. Using a lint-free cloth, wipe off the top of the conductor core to remove any debris or oil that may have adhered. Raise the porcelain up and move it northward toward the bushing.
Okay, I'm going to head north.
Can you reach from there easily though?
I'm going to go a little closer. Can you reach the top of the porcelain okay from there, Lloyd? Okay. All right, Sam, we're going to put that plywood underneath here.
Place plywood boards
Good.
on the floor under the bushing beside the service well, and cover them with oil-absorbent material before lowering the porcelain onto them.
Okay, I'm going to take it just a fraction east. Right there. Perfect.
Using the rolling warehouse ladder equipped with handrails and with the locking mechanism activated, spray the top of the porcelain with isopropyl alcohol.
We're just going to scrub out the interior of the porcelain.
From the ladder, swab around and inside the top of the porcelain using a lint-free cloth attached to a pole. The contamination is from the work environment and should be removed prior to the porcelain being reinstalled on the bushing.
And it's just, the contamination is not anything that, you notice there's a little bit of dirt on the swab. Yeah, it does. There's just a very small amount on your swab, not bad at all.
Yeah, the contaminated, you're saying.
Is from us working in the area with our... So I'm just going to enlarge the ID just slightly.
Trim the ID or inner diameter on the new gasket if required. Slight adjustments may have to be made in order to have a gasket fit properly. Having a gasket fit properly is very important over years of service.
So now we're going to make sure that we're going to glue it in place.
When the fit is exact, then apply
Okay, I'm just gonna
gasket
put some
adhesive
glue.
all around the channel where the gasket will be installed.
That's plenty.
And then lower the gasket on top, making sure it lies flat.
All right, looking good.
Raise the porcelain off the floor to just above eye level.
Okay. Now I'm clear of it, right? So I can go east. Okay. That's what I'm doing then. Are those spacers bonded?
Spray the inside walls and around the base of the porcelain with isopropyl alcohol, and then swab the areas that were sprayed using a lint-free cloth attached to the end of a pole.
Looks good. Yeah.
Using the rolling warehouse ladder and using both hands, steady the porcelain unit as it is being lowered onto the conductor core at the top of the bushing.
Looks good there. How are we doing here? I'm going to go north another 2 or 3 inches. I'd say that's pretty darn good. Huh? Oh yeah.
Lower the porcelain unit down over the main insulation on the bushing as a team member is standing beside it on the ladder and guides it.
Okay, just let go of it a bit there, Lloyd. Yes. Perfect. Still good. Still good. No, I got to keep kind of look around from every direction. I'm going to take it an inch west. Okay, it's coming down again. Okay, we got a lot of space on this side.
Stop the downward descent as required to evaluate the situation from different angles in order to optimize the seating of the porcelain on the central flange.
Okay, I think it's up against your side right now, so I got to go north right now. I'm going to go north a little bit. Try that. I don't know if we have to just push it or something. I think what it is it's a little cockeyed because of the sling. So we're gonna have to just take her down nice and slow. Just gonna have to go north. Okay?
With team members on either side, lower the unit so that it is seated properly on the gasket on the flange.
Okay.
Remove the protective padding from between the slings and the porcelain.
Yeah. Yeah. Just take a rag and quickly wipe this.
Undo the cord used to keep the slings tight against the insulator. Remove the slings and roll them up neatly for storage. When the bushing is in service, the conductor core acts as a conduit for the lead draw conductor from the transformer. One end of the lead draw conductor is connected to the transformer, and the other end is connected to the top terminal of the bushing. In order to optimize the functionality of the bushing, it's important that the conductor core be centered. Using the rolling warehouse ladder equipped with handrails and with the locking mechanism activated, measure the distance from the inner edge of the porcelain to the conductor core at different points along the circumference. If the core needs to be better aligned, adjusting the tension on the bolts holding the retainer plate will help to position it properly. The reason for this is that the retainer plate delivers pressure against the round flange on the bottom of the conductor core at 3 different spots, located where the nuts are under the plate. By adjusting the tension on a specific nut, the position of the core can be changed. If the core needs to be adjusted to move in a southerly direction, then have a team member tighten the bolts on the flange on the north side. The team member on the ladder can request that additional tension needs to be applied and actually watch to see the core move in the desired direction. Measure again to confirm that the core is centered. Replacing the compression system on the bushing, including gasket. With the compression system on its side while on the workbench, apply gasket adhesive around the center of the channel where the gasket will be placed. Lifting it on and off a few times and rotating it helps to distribute the glue underneath and also lets the air penetrate underneath so that it dries faster. Install new O-rings into both channels around the base of the compression springs. Raise the compression system using the sling attached to the two eye nuts on the top plate.
No more than 1/8 of an inch.
When it comes off.
And that's to take the pressure off of that brass nut so that we can unscrew
Move
it.
the system closer to the top of the conductor core sitting in the service well.
And that already gives you enough compression so when
Using both hands while standing on the mobile warehouse ladder, a team member should grasp the bottom plate on the system as it approaches and begin guiding it over the top of the conductor core.
because we've already added that little bit just to loosen that brass nut, we've already compressed that spring more, right? So now you've already got extra compression on it. This isn't gospel, but I would say that there's probably about 3,000 pounds of pressure on those springs.
Once directly over the core, the crane operator should lower the unit in very small increments as guided by the team member on the ladder. The distance between the rim of the metal base of the compression system and the top of the porcelain insulator is very small. For this reason, the crane operator and team member should be in constant communication in order to optimize the successful seating of the heavy compression system onto the gasket on the top of the porcelain.
Because I know this here particular bushing right here, we use a hydraulic system to take the pressure off of the springs.
Oh, really?
Yeah, we use a hydraulic system, and it's got a gauge on it.
Oh, okay.
So when
That's
we,
around 3?
it's around 3,000 to 3,500 pounds, every one of them that we've taken apart. So I'm assuming it's a little different style of spring, but it would have to, because the bushing is the same size, the same amount of gaskets and everything else as this one,
Yeah.
probably works on exactly the same principle, probably the same pressure.
Now, here's a question too, if that's wrong. I just started thinking.
When lowering the system onto the gasket, the goal should be to have the system seated in the middle of the gasket all the way around.
That's great. There's your pen.
All right.
Thanks.
If an adjustment needs to be made after the initial seating, the compression system can be raised slightly and reseated in the correct position.
That's put on and sealed. You're going to draw a vacuum on that overnight?
Yes.
And what sort of vacuum can you achieve?
Remove both eye nuts from the bolts on the top of the compression system. replacing the brass collar and releasing compression springs to put the entire bushing under compression. Using the rolling warehouse ladder equipped with handrails and with the locking mechanism activated, drop the new gasket for the top of the compression system over the core and let it fall onto the plate above the springs. Using both hands, lower the large brass nut down over the conductor core and gently place it onto the threaded section. Slowly turn the nut counterclockwise until the nut is seated properly on the top thread. This will have occurred when a clunk sound is heard, which is caused by the weight of the nut dropping down onto the first thread it will engage when it is turned clockwise. This prevents cross-threading from occurring, which is when the threads on the nut and the core are not aligned properly and can be permanently damaged. Hand tighten the nut to the top of the compression system with the new gasket in between. Using the appropriate size ratchet wrench, loosen the nuts above each spring. It may be difficult to release the pressure on some of the nuts. By using a longer handle on the wrench, more torque will be delivered, and the nut will be loosened easier. When the nuts were first installed at the time the large brass nut above them was removed, each nut was only tightened by about 1/8 of an inch. This is usually enough to allow the nut to turn and is equivalent to approximately a 200 or 300 pound pressure reduction. When loosened enough, manually remove all the nuts and washers from the bolts. By removing all the nuts, a pressure equal to approximately 3,000 to 3,500 pounds will be released onto the tightened brass nut. All the components between the compression system and the lower flange at the very bottom of the bushing will be compressed together very tightly. Some of the nuts may still be difficult to remove by hand. Use the appropriate tools as required to remove all the nuts. Replace oil reservoir tank onto bushing and align fill gauge with capacitance tap port. Begin hoisting the oil reservoir tank in the direction of the bushing in the service well. Using the scissor lift and wearing a safety harness, a team member should prepare to guide the tank onto the bushing as it approaches on the hoist hook. Ensure that the lanyard on the harness is corrected to the railing on the scissor lift. As the reservoir tank approaches the top of the bushing, grasp the tank by its sides and begin guiding it over the conductor core.
Okay, just let go of it for 1 second. I just want to see where it goes. Okay, going down.
Once directly over the core, the crane operator should lower the unit in very small increments, as guided by the team member on the scissor lift platform. The crane operator and team member should be in constant communication in order to optimize the successful seating of the tank on the top of the compression system.
Okay.
Lower the tank all the way onto the top of the bottom plate of the compression system. The two O-rings installed on the bottom plate around the base of the springs will now provide a seal that will contain the oil inside the reservoir tank. The volume of oil that will travel up through the holes in the bottom plate of the compression system and into the reservoir will depend on the temperature that is indicated on the level gauge located on the side of the reservoir. The team member on the scissor lift vehicle should lower the platform to a position that is safe and comfortable to reinstall the screws at the bottom. Normally, the gauge on the oil reservoir is aligned directly above the capacitance tap, located on the main central flange below. With the help of a team member on the floor below, Turn the tank as required to achieve the proper alignment. Reconfirm that the level gauge and the capacitance tap are aligned properly by looking up the bushing. Begin installing the hex screws manually into the screw holes in the plate on the bottom of the compression system. Use an Allen key with an extension arm to make it easier to tighten with. A team member can assist by torquing the extension arm from a different angle if need be. Replacing the refurbished oil gauge on the reservoir tank. Using an Allen key, insert the 4 screws that were removed originally back into the recessed holes on each corner of the gauge. Tighten the screws as much as possible. The level gauge for the tank has a magnet in the back that follows the metal arm on the float inside the tank. The indicator arm on the gauge magnetically follows the metal arm of the float inside the tank so that as the level of the oil increases in higher temperatures, the indicator arm will rise to reflect the change in volume. Install retaining ring on top of oil reservoir tank. Install vacuum fittings for vacuum processing. Install the new O-ring that sits around the outside circumference of the conductor core where it meets the oil reservoir tank. Place the metal collar over the top of the conductor core and align the notch in the collar with the port used for draining the oil and drawing a vacuum. Using an Allen wrench, begin tightening the hex screws on the surface of the collar. To further tighten the screws and increase the torque, use a longer hollow tube to extend the handle on the Allen wrench. Into the port that is used to drain the oil, screw in a quick connect coupling and then attach the proper size adapter in order to connect the vacuum hose. A vacuum will be drawn overnight at 2 torr. The purpose of the vacuum is to test the effectiveness of the new gaskets and seals that have been installed. Negative pressure will also cause the space between mating surfaces to be minimized, thereby maximizing the seal. The Quick Connect adapter simply fits on top of the connector below it. Remove the retainer plate from the lower porcelain insulator. Using an appropriate number of washers to achieve the correct height, insert 2 large eye bolts into the surface of the large flange of the bushing, which is seated in the service well. Ensure that each eye bolt is screwed in tightly by hand. With one team member on the scissor lift and another on the opposite side using the warehouse ladder, secure the slings tightly to the oil reservoir tank by fastening them with 2 belts. This will help to establish equal lifting points on each side of the unit and ensure a balanced lift. Be sure that the metal security buckle on either belt does not come into contact with the level gauge when fastening the slings to the tank. This may damage the gauge. Reposition the belts if necessary and firmly tighten each belt using the buckle.
Beautiful. One more will do it.
Place pads under the slings against the porcelain at the widest part of the bottom of the bushing.
Okay.
This will help absorb the pressure exerted on the porcelain during the lift.
Fairly well.
Slowly lift the bushing until the retainer plate on the bottom clears the top of the well.
Now this was leaking, eh?
Yeah.
You wanna...
Yeah, I gotta go.
Turn her back when it's changing. I gotta spray it over there.
Okay, hang on, I'm gonna take it this way a bit. Okay, let's just give her a little spin, and I'm gonna take it west.
Once it has cleared the top of the well, move it westward to be above the concrete floor.
Okay, going west.
Place the cover back on top of the service well.
Okay, I'm gonna take it down.
Gently lower the bushing onto the concrete floor.
Let's leave it on that angle, a little right there.
This one should be loose already.
They'll be very close.
Use an adjustable wrench to begin loosening the large nuts on the surface of the flange that hold the rods to the retainer plate. One of the bolts may be tighter than the others if it was used to adjust the alignment of the conductor core when the upper porcelain was reinstalled. Remove the nuts by unscrewing them manually.
There we go.
As the crane operator lifts the bush up about a foot, two team members can carefully remove the rods away from the porcelain while sliding the plate out from underneath the small flange at the bottom. Place a plywood board under the small flange at the bottom of the bushing and then lower the bushing back down onto the board. Servicing and replacing seals and parts in the capacitance tap located on the flange. At the base of the threaded section of the port where the capacitance tap is located, there is a metal ridge that needs to be cleaned and scraped to remove old gasket material. To make sure that no debris enters the area below the ridge, insert a section of lint-free cloth into the opening below. Using a chisel of the appropriate size, begin scraping the top of the ridge to remove the buildup of debris that has accumulated. Continue to clean off the ridge by scraping the pieces onto the cloth below. When finished scraping, carefully fold the debris into the cloth before removing it to make sure it doesn't fall back into the port.
Right. Okay.
Install the new washer by sliding it all the way down the shaft. Ensure the gasket is firmly seated on the base of the capacitance tap.
Okay. That's on there now.
Having installed two new gaskets on the red porcelain part with concentric rings that surround the tap, one must also be installed into the port. Slip the red piece over the tip of the tap and at the same time guide it into the opening of the port. Slide the piece down the length of the capacitance tap. The old O-ring that was removed, shown here, was very compressed and had lost much of its sealing effectiveness. The new one that will replace it is shown here and is perfectly round and much more effective. Slide the
Yep.
new O-ring
Just
over
gonna
the
put it on
capacitance tab onto the surface of the red porcelain part with concentric rings below. Use a blunt, round-ended tool to make sure it is firmly in
That's where
place.
that sits. And we're going to put this piece on again. Just going to put that.
Reinstall the brass collar that screws onto the threads above the O-ring and hand tighten as much as possible, holding the tap with needle nose pliers.
No, it's going to be a little bit more than that. It's just going to use a wrench. There's got to be some compression on that O-ring. And also the gasket that was put on originally in behind there, the very small gasket that I put on previously. This is, when we tighten this, it's going to compress that and create a seal on the back side as well. So you're actually creating a seal on the front and inside on the back.
Fully tighten the brass collar onto the tap using an adjustable wrench and holding the tap with needle nose pliers.
Okay, there's our compression. Now I'm just going to tighten up. There's a little locking screw on the top of this little ring here, and I'm just going to tighten that up.
Tighten the locking screw on the side of the cap with a small screwdriver. This will make sure that the cap does not loosen over time.
And that's it. Okay, now I'm going to take some Vaseline. Just going to take a little bit of Vaseline.
Reinstall the metal insert that mates with the red porcelain part with concentric rings, holding the capacitance tap upright by first smearing with petroleum jelly on the underside of the insert.
Okay, just like so. Okay. Now that's going to be installed. I know it's going to be tough.
Begin installing the insert by hand. When it becomes difficult to grasp, use a cylindrical pin wrench to tighten it all the way in place.
Got to get our hair right. There we are. And now I'm just going to screw that in.
Install the new gasket that is seated between the capacitance tap port and the cover for the port. Place the cover to the port over the new gasket and manually tighten the bolts that secure the cover in place. Use a wrench to tighten the bolts completely.
Is that one working better for you? Good.
Returning the bushing to the service well and drawing vacuum on the bushing overnight. Remove the cover on the service well where the bushing will go, and
Okay.
then raise the bushing
Coming
off the
through.
plywood board situated on the concrete floor.
Good lift, pushing team. Good lift. Count down.
Right there. Okay. Pretty good.
Lower the bushing into the service well as it's being guided by a team member.
You happy with that?
I'm pretty good with that. That's fine. That's not going to do anything.
Okay. And you drop the straps, bring them over the side.
Sling and put a choker on that. Bring that hose up to you. Okay?
Using the warehouse ladder, undo the slings from the hoist hook. Loop both ends of a sling through the hoist hook and use it to support the vacuum hose that will be used to draw a vacuum on the bushing overnight.
We're just hooking it up to the crane for a little extra support. Right about there? Oh yeah. I'm going to turn it off for a second. I turn on the vacuum first. Here, hang on a second. Let's get it.
Turn on the vacuum first and try to bring it down to 0.2 torr. That will confirm that the vacuum is not leaking.
Okay, then what next?
Okay.
Step is
The next step is we're going to hook up the hose.
1 second. Take it away.
Connect the hose to the vacuum by pushing it firmly onto the quick connect receptacle on the vacuum panel. Check the vacuum gauge again to confirm there is no leakage from the hose after it has been connected. The indicator needle should stabilize at 0.2. Now it is confirmed that there is no leakage in the vacuum or in the hose. If there is a poor reading during the test, then it must be due to an issue with the bushing and not from anywhere else. Attach the vacuum hose to the quick connect receptacle on the top of the oil
Okay,
reservoir
I'll take
tank.
it up.
Optimize the height and angle of the hose using the